Hello. Today we are going to be working on some new definitions, and you'll see in just a moment. So we are not just talking about numbers anymore. We're talking about numbers and letters together. It's official. You're algebra students. So we have to have some definitions, and you probably heard these before, but I think you should write them on a note card to help yourself kind of keep going back and remembering what they are, and even writing these out for yourselves. So terms are numbers and or letters that add or subtract. That's the key, is they add and subtract. If they multiply and divide, they're not terms. So 2 and x, there are two terms here, because 2 is a term and x is a term, and that's because they're adding. We have y squared minus 4 plus z. There are 3 terms here. Y squared is a term, comma, negative 4 is a term, and plus z is a term. Okay, they're being added or subtracted. Factors are numbers and or letters, so that's similar to terms, but they multiply. Okay, so this was 2 plus x up here. This is 2 times x. So my factors are 2 comma x. Now my factors here, I'm looking for the numbers that multiply to make 15. So my factors here are 3 and 5 and x and x. Those are the numbers that multiply to make 15x squared. And then my factors in the next one are simply just x, y, and z. Okay, now we are going to get into much bigger factoring later in the next lesson, but we're just trying to get some good foundational definitions going. So again, I'm working out of the book. So page 65 is where I'm going to be working out of. So I'm trying to do that so you can always have your book in front of you so that you have that to reference while we're working together. Okay. Okay. So the first ones I'm going to do is where the book is asking you to simplify. And it's like, well, what does that mean? Simplify. We use this word simplify if you watch my video on order of operations. Simplify means to use our order of operations and see what things we can combine. Well, now we are simplifying, which means we can only combine things that are like from the same family. We call them like terms. And remember, terms are things that add or subtract, right? So we have, I'm just going to go through and identify kind of like the family that we have here. We have the A squared group, we have an AB group, we have another AB group, and then we have a B squared group. So the ones that are the same groups can be combined, which means they can add or subtract. So those are the only ones that are like terms. Okay, so the 12a squared doesn't have anybody to combine with. And then we have plus 8 ABs and we have negative 15 ABs. And so there's more negatives than positives. And so we take the difference between them. So we have a negative 7 of those AB terms. And then the B squared term didn't have anything to combine with. So make sure you carry the negative. So negative 10 B squared. That's all they want us to do. Now remember too, while we're working, all of the odd problems have answers in the back of the book. So you can always take time to try some of those and check your answers. I'm going to mainly pull out some of the positive ones because you don't have answers for those. And I want to just give you an extra experience. So the next one, they still wanted us to simplify, but we have this grouping here subtracting this grouping. And so because we want to subtract this entire group in the parentheses, we have to use that distributive thing, right? So we have to distribute this negative to each term. There's 3 because there's this 2x squared term that is separated by an addition. Remember, terms add or subtract. And this term and this term. So this negative gets distributed. So I'm just going to rewrite the entire first parenthesis here, negative 4a squared plus 5x minus 3. And then I'm going to apply this subtraction to each of the terms inside here before we go ahead and combine like terms. So this will be a negative 2x squared, and then a negative x, and then we're taking the negative of a negative 7, so that becomes a positive 7. And we really no longer need this parenthesis because we're just combining like terms. So now combine like terms. Okay. So I'm going to go through and just kind of circle the things that are like. So I have this, this is 16, right? And I don't know why I wrote A's here because this was not an A, that was an X. That should be X squared. I thought that seemed weird and you probably did too. You probably already caught it. So, okay, so we have the X squared terms, those are alike. And I have negative 4 and negative 2. So they're both negative. So we get a negative 6x squared. And then we have the X term, and then I have an X term here. Make sure you've got the sign that goes with it to the left. So we have a positive 5 and a negative 1. So that becomes a positive 4x. And then we have the constant on the end, this negative 3 and a positive 7. And so that becomes a positive 4. So when we combine the like terms, we have a negative 6x squared plus 4x plus 4. Good job. Okay. Then we talked about factors. So we're not going to factor today. Like I said, there's going to be a whole new video about that coming, but that you can check out. But we do want to multiply. So we need to know how to multiply before we can factor. Remember, factors are things that have been multiplied together already. So there's factors that are things, and then there's factor, which is a verb. So we're using this word factor in a couple different forms of speech, which we're not really in an English class, but we do talk about those things. So there's factors that multiply, and then there's the verb that says to factor. We're going to do something, an action, and we're going to do that in the next lesson. But we are going to multiply factors together. So we have this multiplication here because it's next to a parenthesis. And then we are going to multiply this negative 3x times everything in this parenthesis. So we're going to do that distributive property again. We're going to distribute. And all of this negative 3x gets multiplied by this first term. And then it's going to get multiplied by this term. And then it's going to get multiplied by this term. So we should have 3 multiplications. 3 multiplications. So let's go ahead and write that out. So it's going to be a negative 3x. And I'm just going to put these in parentheses so I can see what I've multiplied. And then I've got a negative 3x times the negative 6x. And then I have a negative 3x times the negative 4. So there's my 3 multiplications. See where I multiplied this negative 3x times each of the things in my parentheses. And now I can go ahead and actually complete that multiplication. So a negative 3 times 5 is a negative 15. And I have an x and an x squared. They're like bases, so we can add their exponents. So there's just an unsaid 1 there. So we have x to the 3rd. And then a negative 3 times a negative 6 gives me a positive 18. And this is x times x, so that's an x squared. And then I have a negative 3 times a negative 4, which is a positive 12x. And it looks like we don't have any like terms because we have an x cubed, an x squared, and an x. So we have simplified all that we can do. Okay, no, we're getting bigger. So now we have x minus 3, which is 2 terms, x and minus 3, multiplied by this parenthesis here that has 3 terms, which is x squared, 3xy, and 9y squared. Those are my 3 terms. And so if I take 2 times 3, that means I should have 6 multiplications, 6 products. Just like we had 3 big multiplications up here, we're going to have 6 of them. So when I get big like this, sometimes it's nice to write them underneath each other. So I'm going to do my x first. So x times x squared plus x times 3xy plus x times 9y squared. Make sure I copy this correctly. Okay, and now I have to do everything multiplied by the minus 3y. So I'm going to do, now I'm going to have minus 3y times the x squared minus 3y times the 3xy minus the 3y times the 9y squared. I did not leave myself enough room. Those are parentheses around that, by the way. Okay, I'm going to kind of shift everything over so there's room. So x times x squared is x cubed plus 3, and x times x is x squared y plus, no like basis, so we have 9, and I always go in alphabetical order, so 9, and then the x, and then the y squared. Those are just some rules that we try to follow in math. And then we have a minus 3, and again, my x, I'm going to put first for alphabetical reasons, x squared y, and then a minus 3 times a 3 is a minus 9x, and that's a y times y, so y squared. And then we have a minus 3 times a 9. So that's a minus 27. And then that's y times y squared is y cubed. Okay. So I'm going to circle, I'm going to go through and I'm going to see if it has any like terms. If not, I'm going to circle it. So x cubed, there are no other x cubed. So that one's done. So I'm just going to write that. Okay. Are there any more x squared y's? No. Oh, there's an x squared y. So I'm going to underline the x squared y, x squared y. Okay. So there's a positive x squared y and a negative x squared y. Well, it looks like those cancel out. Okay. That makes that easy. And then we have this xy squared. Okay. And then there's another xy squared, but that's a positive 9 and a negative 9. And it looks like those cancel out. This is nice and easy. And then we're left with this y cubed, which doesn't have anything to combine with. So we just write minus 27y cubed. Well, that's cool. You do not know it yet, but this is a special kind of multiplication. It multiplied into what is called a difference of 2 cubes. And remember that when you multiply and you factor, they're opposites of each other. Factoring is like pulling apart. It's like dividing almost. And we multiply and then we pull apart. So here we're multiplying, but when we factor in the next lessons, we're going to actually start with something like this difference of 2 cubes, and we're going to factor it back to this. It's pretty cool. Okay, so our last two are actually going to be a little more simple. So up here we had 2 terms times 3 terms. We had 6 multiplications, right? 1, 2, 3, 4, 5, 6. They're separated by additions or subtractions. So now we have 2 terms multiplied by 2 terms. So we have 4 terms. We should have 4 multiplications is what we should have. So this, when we have 2 terms times 2 terms, we can use like our FOIL system. They teach that in the books. FOIL is first, you multiply your first terms. So we're going to multiply 5a and 2a. And then you're going to multiply your outside terms. So that would be, this is an outside and this is the outside, they're on the outside. So that would be plus 5a times 1. And then you're going to, that's FOIL, F-O-I. You're going to do your inside terms. So your insides are this -4 and this 2a. So -4 times 2a. And then FOIL is F-O-I-L for last. So the last is the -4 and the 1s. Now, you can use the FOIL, but it only works when there's a 2 terms and 2 terms. So it wouldn't have worked on number 42. So that's why I like to just think of it as just distributing using my arrows, but everybody's different. So we did our first, we did our outsides, we did our insides, and we did our last. Okay, so let's go ahead and get these multiplied. So we have 10a squared plus 5a minus 8a minus 4. And then we have like terms in the middle. So we end up with 10a squared plus 5 and minus 8 is a minus 3a minus 4. So fun, so fun. Okay, 46 is our last one for this little lesson here, lesson 1.5. And I'm going to let you get started on that one on your own. Okay. So I'm going to do my first, so 7 times 6. And then my outsides is going to be plus 7 times a -3t. And then my insides is going to be a minus t times a 6. And then my lasts are going to be the minus t times the minus 3t, -3t. So we end up with 42, subtracting 21t, subtracting 6t plus 3t squared. We have some like terms. So we have 42, and then a -21 and a -6 makes a -27t plus 3t squared. Okay. And I like to write, this is a fine answer. I like to write my variable terms first. So I would switch this around, going with my highest exponent, descending. So 3t squared minus 27t plus 42 is what I would do there. Either of those would suffice. So I hope you've had fun and learned something or refreshed on some things about terms and factors from lesson 1.5 and multiplying these. They are actually polynomials, what we call them. Polynomial means many terms. So we talked about terms, and these are many terms being multiplied together. That's a polynomial. Let's write that out. Polynomial, poly means many, nomial is our term, so many terms. You did it. So catch me back for some factoring. It's going to be super fun. See you later.